This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach us some algebra right now. This is lesson 3.3 on function notation. And the question we're going to ask today is how can you use function notation to represent a function? So we have this new kind of phrase, or this new kind of term, function notation. We know what a function is already from our previous lesson. Notation. What does notation mean? Notation is how we write stuff. So, music, when I deal with music, we talk about notation. So the staff of a musical staff and its clef and its notes. This is all a kind of a written language developed for music. This is notation. It's a written language. It's how we write something. So kind of like notes, right? Not notes like musical notes, but taking notes. That's notation. Okay, so function notation, it's a shorthand way of writing math. So we name a function, we give a function a name. And in this case, we say f. The name of this function is f. The function is 3x plus 2. So we say f of x. For this, we'll say f of x equals 3x plus 2, 3 times x plus 2. It can have another language, g. G of x equals negative 2 times x plus 1. So we have to define a function, and we give it a name. We define it and give it a name. That way we don't have to write this thing all the time. We can just refer to this as we do different problems that are the same problem over and over, essentially. This one, we just refer to this. And let's take a look at some examples here. It says, evaluate f of x when, evaluate f of x equals negative 4x plus 7 when x is 2 and x is negative 2. Okay, so that means f of 2, okay, so I'm going to replace the x with 2 in this case. F of 2 equals negative 4 times 2 plus 7. So f of 2 is going to equal negative 8 plus 7. F of 2 equals negative 1. Pretty easy. We just kind of substitute that in. And the thing that's confuses some kids is they kind of think they want to make this multiplication, but this isn't. This is one reason when we multiply coefficients and variables, we put the numbers first. So it doesn't look like function notation. It doesn't look like an exponent. Okay, and we put this in parentheses. Okay, and when x equals negative 2, f of negative 2 equals negative 4 times negative 2 plus 7. Okay, so negative 4 times negative 2 is positive 8 plus 7. So 15. F of negative 2 equals 15. Pretty easy there so far. Because this is just the math is easy. It's just getting used to this new way of looking or writing math with this shorthand notation. The next example, let f of t be the outside temperature in degrees Fahrenheit, t hours after 6 a.m. Okay, so 6 a.m. is kind of like our 0 hour, and then t hours is the number of hours after 6 o'clock. Explain the meaning of each statement. So f of 0 equals 58. Well, so the meaning here is what? It's 58 degrees at 6 a.m. because it's 0 hours from 6 a.m. So it hasn't really changed. The time hasn't changed. We're still at time 0, and this is t hours after 6 a.m. So it's 0 hours after 6 a.m. F of 6 equals n. Well, this is the temperature 6 hours after 6 a.m. So this is at 12 o'clock, at 12 noon. The temperature is n degrees. And f of 3 is less than f of 9. Well, again, this is 3 hours after 6 a.m., so this would be the 9 o'clock temperature is less than 9 hours after 6 a.m. would be what? 3 p.m. This, I'm going to put a.m. here. Would be the 3 p.m. temperature. Okay, so this is hours after 6 a.m. All right, so that was pretty straightforward. Once you get these, this idea in your head that these numbers don't really mean what they look like they mean, they're hours after a given time. Okay, so for h of x equals 2/3 x minus minus 5, find the value of x for which h of x equals -7. Okay, well this is pretty simple. We're going to just substitute. -7 is h of x, which is this. So I have -7 equals 2/3 x minus 5. Okay, so let's go ahead and add 5 to both sides. So this is -2 equals 2/3 x. And to clear the fraction, I'll multiply both sides by 3/2, the reciprocal. So I get left with x over here, because 2 and 2 cancel, 3 and 3 cancel. -2 divided by 2, -1 times 3, -3. So x is x equals -3. Let's make sure we answer the question here. Find the value of x for which h of x equals -7. So x is -3, or we can say h of -3 equals -7. Okay, but they're really just asking for the value of -3. I mean, the value of x, which is -3 in this case. Okay, moving through these examples pretty quickly. Make sure you get all these in your notes. And finally, I think this is finally, we're going to do a graph here. Now, when it comes to graphing, you can think of the f of x as really the y. It's the output of this expression here. So x is the input, f of x is the output. So you can think of it as y. So we can graph a function, but just think of the f of x as the y value. Okay, so usually when we graph linears, we haven't really done a lot of this yet, but I like to use 3 values, -1, 0, and 1. It keeps us focused around the center of the graph, and they're easy to kind of do in our heads, right? So -1 times 2 is -2. -2 plus 5 is 3. 0 is always easy because it's always going to be the plain number out here, because 2 times 0 is 0 plus 5 is 5. It's always that number. And then 1. 2 times 1 is 2. 2 plus 5 is 7. So now I've got 3 ordered pairs here. -1, 3. 0, 5. And 1, 7. Those are my 3 points. And let me find a good line here to use. This looks like a good line. Like that. Yeah, so you can think of this when it comes to like graphing and it comes to like thinking input output. We're basically the same as the y value when it comes to ordered pairs, when it comes to graphing and things like that. Okay, that's it for now. Another little word puzzle here, and I'll see you in class. Thanks a lot. Have a great rest of your day. Bye.